once again, our multivalued student. My name is Confident and welcome to our continuation of the topic on waves, sound and light for grade 10 physical science. And I'm continuing here. We have already looked at transverse pulses. We are focusing on transverse waves, and if you're joining us for the first time, you have missed out on quite a lot of videos, and I would encourage you to join me and subscribe so that you can be able to be notified. But now I will say check the last 3 videos that I've covered so that you can understand from transverse pulses to transverse waves, and the also definition of terms. Let me see here. We defined some terms. It was where there, see, speed of a wave, frequency, period. We looked at the amplitude here, the crest, the trough, the wavelength. So we just looked at a few things. So that's why I'm saying it's good if you're subscribed or check the previous videos. Now there's another one. In this section, I'm just looking at the activity and the questions that you can expect in an exam considering these transverse waves. It says, consider the following diagram of a wave with a frequency of 12 Hertz. Now it says AB can be described as what? Look at AB, and what did you call AB? Don't be tempted. Is it B, the amplitude? The answer is no. That's not the amplitude. Remember, I said always focus on your reference line, the rest point, the point of equilibrium. We call this the rest, and the amplitude is the distance from the rest to crest. See, from rest to crest. So that's your amplitude. All right, but here look at A and B. It's not that, and you can see that O, we say the amplitude is the distance from what? From rest to trough, the lowest point. But this distance has got 2 things. It's got like, there is an amplitude, there is an amplitude. If you look at the line given, it's like it's got 2 amplitudes. From here to there, that was an amplitude, and another one again from where is this? From here to the bottom there. Do you see that? That's another amplitude. That's why the answer there is what? Twice the amplitude, D. Are you with me? Next question. If a wave has a frequency of the wave is what? 6 Hertz, the units are correct, and the wavelength is 10 meters, the units are correct. What is the speed? Remember the formula? V is F lambda. Come on. Then straightforward, F is 0.6 times wavelength is 10, and that is 6 meters per second, and the answer becomes what? C. So these are questions that you can just use as standard questions for preparation. Now look at this. These will require you now to kind of use a little bit of thinking here. On the answer sheet, label the given wave as M. On the same sketch, draw, okay, on the answer sheet, label the given wave as M. So this wave, we are going to call it M. Then says, on the same sketch, draw a wave traveling at the same speed, meaning the medium did not change. You remember we said wave is not affected by speed, with half frequency of a given wave. Now, if frequency is half of frequency is to 2 times of wavelength. Remember, if the frequency is half, the wavelength is twice. So if this was the wave, they didn't explain as such whether this is time, but let's assume this was the wavelength of a wave. So now the wavelength is going to double. See, from, if you look at this, from 2 is half a wave to 4, so that's a wavelength here. So the wavelength was what? Let's call it meters, 4 meters. But now this becomes half the wave, so the wave will move from 4 to 8 meters. See that? So when you're sketching it, you're going to sketch here to say at 4, where there was 4, that is the new amplitude. So you're gonna have a wave like this where there is 4, and then where there is 8 is where this wave is gonna do. See what's happening? And then again, where there is from 8, where there is 12, that's where this wave is going to turn, like this, right? And then after that 12, this wave needed further like this. So from 4, 8, 12, it needed 16 somewhere there. So you see that? So the wave was like this. Are you getting that? So in a way, what happens? Remember, the frequency is half. When you halve the frequency, the wavelength will increase. Are you with me? So in other ways, decrease frequency, increase wavelength. Increase frequency, you decrease the wavelength. Are you with me? So this was the answer there. So if they were going to say, just out of argument's sake, let's say if they were going to say here, sorry about this, I'm trying to wrap here. If maybe they said the frequency is doubled, out of interest sake, instead of half is 2 times f. If they do that, the wavelength is half of the wavelength. So what you do here, you see this point, this now becomes half a wave, this becomes now a full wavelength. So what I will have will be a wave like this. Is the highest point, okay, not the highest point like this, it's gonna come and have a high point there and 10 there. See, there are 2 waves now. See what's happening. So they've got like double the waves. So there's more waves in every 2. The half a wave here, half a wave, you have got 2 waves. The half a wave, you have got 2 waves. Just like that, just like that. You understand? So that is the part there. Alright, next one. The figure below shows a transverse wave motion. The period of the wave is 0,2. Remember, when they say period, you must know it's t. So t is equal to 0,2 seconds. Next question. Calculate the following: the frequency of the wave. Remember, when they give you period, you know the frequency. What is frequency? F is 1 over t. Frequency is 1 over 0,2. You must always remember that formula. Frequency is inversely proportional to what? To period. So this is 1 over 0,2 is 5. So frequency is 5. How do you measure frequency? It's in hertz. Are you with me? Next question. That was 3 marks. The speed of the wave if the distance d equals 3 meters. Let's look at d now. The speed of the wave if the distance d is equal to 3 meters. 4 marks. Now look at distance d. You see, starting from this point to that point, and you can if you ask yourself, is this the wavelength? No. Remember a formula for v. V is equal to f times lambda, frequency times wavelength. I know the frequency already. V is equal to 5, but my wavelength now, d is not equal to wavelength. Remember, what is the wavelength? Wavelength is the distance from crest to crest. So look, this is the distance. That's the wavelength. And then this is another wavelength. Do you see that? So if this was wavelength and this was wavelength, and they told us the whole distance d is 3 meters. So here the whole distance is 3 meters, meaning this is 1,5 and this is 1,5. Seeing that? So you multiply that times 1,5. Then you get your v, which is 7,5 what? Meters per second. Or you can say meters, you use this one, second with a negative. Alright, next one. Write down 2 pairs of points which are in phase. Very important now. write down two pairs of points which are in phase. Let's look at this wave. Remember, in phase meaning they are on the same point, consecutive, meaning when one is going up, the other side is going up. Look at A, for example. It's on the left hand side. And look at D on the next wave. Remember, that's the next wave. It's on, because the wave started from here. If it starts here, let's call it X, it will end here in Y. There is a new wave starting now. So that's why A and D are in phase. See, that's a wavelength on its own. So it's A and D. Which other wave can you say are at the same point? Look at it. There, B and F. So if B was about to go down, even F will be about to go down. So the next one is B and F. We can say C. Look at C and what? And E. No, they're already showing a bit different side. So they're in phase. Now the next one is the two pairs of points in phase 2. The amplitude of the wave motion. Write down the amplitude. Let's look now when they talk about the amplitude. Remember, we say the amplitude is that distance from rest to the top. That is your A for okay, R. They use the word R, but let me write amplitude. Doesn't matter, can be that. That's your amplitude, can be that. Or it can be this lower position, the trough. This is still the amplitude. But look what is interesting. They gave us from the top to the bottom. So they give you the half of that. You see that the amplitude was half. So if this is 30 centimeters, so you can see that the amplitude is 15 and 15. So what is amplitude? The amplitude is 15 centimeters. Don't say 30 centimeters. No, that is too long. This is the one where they say from crest to trough, then you divide by 2, then you get the amplitude. Alright, so that is the first part. Okay, it was an interesting question. Let's move on to the next question. Here it says, you see, these are previous papers. Study the two transverse waves P and Q as shown. Wave P is the solid line and wave Q is the dashed line. Alright, the position in millimeters. Be careful, they are dealing with millimeters. The time in seconds. And they told us B to D here is 100 meters because we are studying this. Question: write down one difference and one similarity between wave P and Q. What is the difference? The first part you can notice is the size. Look at this. We call that the amplitude, right? So the amplitudes are different. I think you can see. One different is the amplitude here, and difference is their amplitudes. Alright, and then what about similarity? What is the same? It is their wavelength. Look at this. Their wavelength is the same, crest to crest. Similarity is their wavelength, same wavelength. Alright, you get 2 marks. Next question. They're saying for wave P, write down. Let's focus on P with a solid line. 2 points that are out of phase. 2 points that are out. You know, they are out of phase. Very open question. Look at A. A is going down and B is now going up. So you can say A and B. Any. Or you can say B and C. Or you can say C and D. Or you can say A and D. Or you can say B. No. Yeah, that's it. Or you can say A and D. And what? Yeah, that's it. They are out of phase. Okay, if they were saying in phase A, C is in phase, B, D is in phase, you see. And then the amplitude of the wave. Now, what is the amplitude of the wave? They're talking about P, remember? There it is. it's what? 15. See that from 0, it's 15 here, it's 15 millimeters, but you need to divide that by 100, by 1,000. Millimeters to meters, you divide by 1,000, or you multiply 15. If they give you millimeters, you say times 10 to the power negative 3. That is that. Simple is dividing by that, which would be 0, then into that 0, into that 15 meters. That's the amplitude. And then define the term frequency of a wave in words. You need to know such definition. Frequency, what is it? Is the number of waves, what? Passing a given point in 1 second. Number of waves passing a given point in 1 second. They need you to know that. And then continue. For wave pattern Q, calculate the following: the frequency of the wave. Now we're in pattern Q. We want to find the frequency of the wave. Now, when we are talking about this part, frequency, see, they are given time, and you can use the concept of period. Remember the formula that they used on period to say period F is equal to 1 over T, and we did define what is period. Or actually, let's use the definition. Let me not go far. Let's use the same definition. They say define frequency, see, and then they ask you what is the frequency. We say it is the number of waves passing a given point in 1 second. So let's see here whether we can get our 1 second. If we divide these like this is time in seconds already. See that? So if from here to here it's 1,5, so waves 0,5. It's a bit tricky, this scale, the way they are using it, this and the half there. Okay, let's count how many waves, number of waves passing per given point in second. How many waves here for P? From here, this is 1 wave, and then we've got 2 waves, right? So we have got 2 waves. Frequency is 2 waves. They took how many time? They took 3 seconds. You see that? So it's 3 over 2, which is equal to what? What are you gonna have? Am I right? Frequency is the number of waves passing a given point in 1 second. So it's per second. So what are you gonna have there? It is, I think, 0,667 hertz. Are you getting that? Or let me try another one just to see if I'm picking this correctly. What about this frequency here? If I can say from here to here, it's a wavelength, you see? Okay, actually it's not wavelength, it's, look at this, from here to here, it's the time 1 wavelength here is equal to what? 1,5 seconds. You see that? 1 wave is called 1,5 seconds. So we said frequency is the number of waves passing a given point in 1 second. So what is the wave, the period there? Period T is equal to what? 1,5. And we said what is period? Period is the time taken for 1 wavelength. So you can use now F is 1 over T, which is called 1 over 1,5. Then let's try and see whether it gives us the same thing here. If you use that 1 over 1,5, and then it's the same 0,667, so it's the same 0,67 hertz. So it doesn't matter whether you are going to say frequency, the number of waves here, there are 2 waves in 3 seconds, or you look at the period, how many waves pass in one wave, how long does it take to pass this 1 wave? That's your period. I repeat again, from 0 to 1,5. That's a wavelength. See? One wavelength. So the thing is, frequency says the time taken for that one wavelength. That's, the period. Period T is equal to time taken for one wavelength. And what was the time? It is equal to 1,5. Then you use the formula T into that. Then you get the answer. Alright. Then the last question here, they are saying speed of the wave. Now you know that V is equal to F times lambda. Now you've got two formulas of V is equal to lambda over T, which you know your T and your lambda. Where is the wavelength? They gave us here the wavelength 100 millimeters, and I told you what to do. You convert that to meters, which is 100 times 10 to the power negative 3. Always multiply by 10 to the power negative 3, or you can say 100 divided by 1000. Alright, so when you multiply, the wavelength is 100 times 10 to the power negative 3, which is meters, over time, which is 1,5. It will give you the answer. Or we can say frequency times wavelength, which was 0, we got it here as 0,67. remember, 0,67 times wavelength, which is 100 times 10 to the power negative 3. Using these, we will still get the same answer. Let's check. The first one is 100 times 10 to the power negative 3 over 1,5 gives us frequency as velocity as 0,067. Let's try the other one. 0,67 times 100 times 10 to the power negative 3. 0,067 is the same answer. So 0,067 meters per second. Even here it gave us 0,067 meters per second. That's the velocity of the wave. Alright, so guys, that's what they bring in the question whenever you are answering such questions. And then now look at the next one. It says question 2, study the following diagram and label A to D. Now start the following diagram and label A to D. Okay, we need to label A to D. What is A? From crest to crest is the wavelength. So A, you don't put the sign, write in full, wavelength. And then what about B? We say it is the crest. What about D? Is the trough. Can you do that? What about C? You know better. Is the amplitude. You're right. Difficult? No. Next one. The diagram below shows two waves A and B on the same wavelength but with different amplitudes crossing each other. Look at this. Wave A is solid line and wave B is the smaller one. Now what type of wave is represented by the pattern? This is a transverse waves. There are two types of waves, remember? This one is called a transverse wave. And then which circled number 1 to 4 points represents one cycle? Okay, one cycle. Remember, one cycle, it can be like from here, you go all the way to there, it's one cycle. So we need the cycle part. I think that it is 2. Look at this. 2, you start from this left and you go on to half, then you go back. So it's 2 to 4. Alright, that is one wavelength. Determine the following for wave A. Let me erase this part. Let's come back to wave A. Remember, wave A is what? Is the solid line. So determine the following frequency for wave A. Now, what is our frequency? Okay, they never gave us this, but there's some writing there, which is time, and this is position in meters. Now, we said with frequency it's a matter of saying frequency is number of waves you divide by time, or you just say frequency is equal to 1 over t, period. Now period is look at the full wavelength and how long it took. That is a period. Now a full wavelength starts from here, you go all the way, you go all the way, you go all the way for A. There is a full wavelength. So what is the period? The period here, t, is equal to 1 second. Are you getting that? What is frequency? F is equal to 1 over 1, which is equal to 1 hertz. You see that? That is the simpler one that you can just count how long it took for one wave. That becomes the period. Then use the formula as t is equal to 1, F is equal to 1 over t. The period we just did there, period t is equal to 1 second. The amplitude, for the amplitude, you can see the amplitude there. They trick you again. This is 20 centimeters. What about from here to there? The amplitude is that distance from crest to rest, which is 20 divided by 2, which is 10 centimeters. Alright. Then says draw the shape of the resulting wave as two waves A and B cross. On your diagram, show the resulting amplitude. So they want these waves. I'm not going to draw it somewhere else. I'll try to sketch it here. These waves are going to cross. As they cross like that, look what is going to happen. Remember, constructive interference, A and B crest is going to be plus, so you'll have a longer wave. Same wavelength but longer. Constructive what? So what they want to say is this: constructive interference. You understand? So if they were adding, if they gave you that but they didn't give us, they're gonna add that and the 10, so it must be longer. Just know that you need a longer line than the two waves. Alright, constructive interference. And then what wave property is illustrated in 2.24? What is this property? It is called superposition. Superposition. The principle there is superposition. And then actually I'm answering this wrong. This is the principle, and I say name and describe the principle. But what wave property? Property of wave is constructive interference. It's a property, constructive interference. And name and describe the principle. The name there, the principle behind is superposition. It's called the principle of superposition. And describe it. What happens? This is superposition, and then we're saying superposition is the addition of waves that are moving in the same line of action. Is the addition of waves that are moving in the same line, of action. Or when two waves move in the same line of action, when they interfere, they add or they subtract. If they move in the same line of if they are moving in the same line of action, they add. So superposition, there is the addition. But if they are moving one in the opposite sides, they subtract. So superposition is the addition of two waves that are moving on the same line of action. But you can just get here, I think the best one is, let's go to the definition of superposition here. What did you say? I'm looking at that. Superposition, do we have it? It's before that. Was it before that? Then there. the addition of the amplitude of two pulses that occupy the same space. So superposition is the addition of the amplitude of two pulses. And then I think that is good. Yeah, the addition of the amplitudes. That's true. Let's just leave it there. The addition of the amplitudes of two waves in this case. So here if they say describe superposition, the principle here is the addition of the pulses of the two waves. Okay, so guys, we've come to the end of our lesson here. This was also where we're looking at what? Some activities, but look at the next one. The second type of mechanical wave are the longitudinal waves. Now, these are also very important. That's where we introduce sound waves as well as ultrasound. Don't miss the next lesson. Be subscribed, join me, because without knowing sound waves, you are still not done. Without knowing electromagnetic waves, you are still not done. Thank you.